Have you ever wondered what the world is made of? Everything around you, from the air you breathe to the ground you walk on, is made up of tiny particles called atoms. And these atoms can exist in different states of matter. The three most common states of matter are solids, liquids, and gases, but there are many other states of matter, both common and uncommon. Did you know that there is a state of matter so dense that a teaspoon of it would weigh as much as a mountain? It's called strange quark matter, and it's just one of the many fascinating states of matter that we'll be exploring in this podcast series. So what are the different states of matter, and how do they differ from each other? Solids. Solids are a state of matter in which the particles are held together tightly in a fixed position. This is why solids have a definite shape and volume. Solids can be made up of atoms, molecules, or ions. Some examples of solids include ice, wood, metal, plastic, glass. Solids have a variety of properties, including hardness. Solids are resistant to deformation. For example, ice is harder than water, and metal is harder than wood. Brittleness. Solids can break when they are subjected to stress. For example, glass is brittle and can break easily if it is dropped. Elasticity. Solids can return to their original shape after they are deformed. For example, a rubber band can be stretched and then released, and it will return to its original length. Malleability. Solids can be bent or pounded into different shapes without breaking. For example, gold is malleable and can be hammered into thin sheets. Ductility. Solids can be drawn into wires without breaking. For example, copper is ductile and can be drawn into thin wires. Liquids. Liquids are a state of matter in which the particles are held together loosely and can move around freely. This is why liquids don't have a definite shape, but they do have a definite volume. Liquids can be made up of atoms, molecules, or ions. Some examples of liquids include water, oil, milk, juice. Gasoline liquids have a variety of properties, including fluidity. Liquids can flow and change their shape. For example, water can flow from a pitcher into a glass. Surface tension. Liquids have a tendency to form a thin layer on surfaces. This is why water beads up on a waxed car. Viscosity. Liquids have a resistance to flow. This is why honey flows more slowly than water. Capillarity. Liquids can rise in narrow tubes against gravity. This is why water rises in a straw. Gases. Gases are a state of matter in which the particles are not held together at all and can move around freely in all directions. This is why gases don't have a definite shape or volume. Gases can be made up of atoms, molecules, or ions. Some examples of gases include air, nitrogen, oxygen, hydrogen, carbon dioxide. Gases have a variety of properties, including diffusivity. Gases can spread out evenly in a container. For example, if you spray perfume in one corner of a room, the smell of the perfume will eventually spread throughout the room. Compressibility. Gases can be compressed into a smaller volume. For example, air can be compressed in a bicycle pump. Expansibility. Gases can expand to fill a container. For example, if you leave a balloon in the sun, it will expand as the air inside the balloon heats up. In addition to the three most common states of matter, there are many other states of matter, both common and uncommon. Some examples include plasma. Plasma is a state of matter in which the particles are so hot that they have lost their electrons. Plasma is the most common state of matter in the universe, but it is rare on Earth. Plasma is used in a variety of applications, such as fluorescent lights and plasma TVs. Bose-Einstein Condensate, BC. A BIC is a state of matter that occurs when a large number of atoms are cooled to a very low temperature. BCs have unique properties, such as superfluid flow and the ability to tunnel through barriers. BCs are still being studied by scientists, but they have the potential to be used in a variety of applications, such as quantum computing and atom interferometry. Fermionic condensate. A fermionic condensate is similar to a BIC, but it is made up of fermions instead of bosons. Fermionic condensates are even rarer than BCs. Strange quark matter. Strange quark matter is a hypothetical state of matter that is made up of strange quarks. It is thought to be very dense and stable, and it may exist at the cores of neutron stars. Strange quark matter is still being studied by scientists, but it has the potential to be used in a variety of applications, such as exotic energy sources and propulsion systems. So that's a brief introduction to the states of matter. In the next episode, we'll take a closer look at solids. We'll discuss what makes solids different from other states of matter, and we'll explore some of the amazing properties of solids. Why did the solid want to become a liquid? Because it was tired of being so stiff. I hope you've enjoyed this episode of the States of Matter podcast. Join us next time for our episode on solids.